Welcome back to part 2 of this tutorial. In part 1, we learned about the iCon hardware and some Pynapse basics, including the Pynapse state machine. We created this simple flowchart in Pynapse using just the always state. Using just the always state is a clever way to program something quickly, but I'm going to show you another way of doing things that makes use of the Pynapse state machine. We'll add just a few more building blocks that will help you scale up to much more complicated experiments. Let's say we want to build out the following experiment. We light up the nose poke LED, and the subject has to put their nose in that port within a certain period of time to get the reward. After the reward or failure, we loop back to the beginning. The flowchart for that might look like this. This diagram was created in a program called draw.io. There's a link in the description. It has a free and intuitive editor to make these diagrams. I strongly recommend you draw out a flowchart of your experiment, including all I/O, before starting to code it. This helps you plan out all the different experiment states that you'll need in advance, and the logic that will define what the state transitions look like. If you ever share your experiment, including reaching out to TDT for support, this is a useful reference point of the design you are trying to achieve. We previously set up all the iCon I/O in the last section. This flowchart will act as a guide while coding up our states. Each of these colored boxes represents a state. This diagram represents all the possible state flows in one trial. This text at the bottom of some of these states, success and failure, are called metrics, which are variables that will track over the course of many trials. Before we can use metrics in our Python code, we have to define them on the Metrics tab. The only option we have is to create global metrics. Right-click to add our success metric. These are basically like global variables that can be adjusted anywhere in our Python code based on the behavior of the subject. We can add a runtime plot window and then turn on individual metrics for plotting at runtime. Right-click and add our failure metric. Later on, when we introduce the session manager, we'll organize these by trial and by blocks of trials in this left pane. We have all our metric assets defined, so we can get to work coding this experiment. The first thing we'll do is clear the always state and replace it with the pass placeholder. Instead of clicking the commit button, we can use the F7 keyboard shortcut. Let's add our first state, the pretrial state. We'll do this from the code tree. Append a state after always and name it pretrial. Now we need to add our methods. Pretty much every state you'll ever make will have the stateEnter method. This method runs as soon as Pynapse switches into that state. Let's add the skeleton code for all of our states first. When the pretrial state is entered, we'll check the status of the nose poke. We use the p_state asset to move between states. If nose poke is on, we use the setTimeout method to wait 5 seconds and enter the pretrial state again to check the nose poke again. If nose poke is off, we use the switch method in p_state to move to the trial state. In the trial state, we turn on the LED. There are two possible outcomes from this state. If nothing happens after 5 seconds, we'll switch to the incorrect state. If we do get a nose poke in that first 5 seconds, we'll move to the correct state. We want to turn the nose poke LED off after we leave the trial state. Rather than turning off the LED in the state enter methods of both the correct and incorrect states, we can use this state exit method in our trial state. This runs right before the state changes and will turn off the LED. In the correct state, we will increment the success metric, fire the reward, and then return to the pretrial state after a 2-second timeout. In the incorrect state, we will increment the failure metric, and return to the pretrial state after a 5-second timeout. This flowchart is automatically generated based on the Python code. It shows the possible state transitions and where the iCon inputs and outputs are processed. We can directly compare this auto-generated flowchart to the one we made in draw.io. You can click on a state and the Python editor will jump to that state so you can fix any obvious design issues. You can keep the flowchart visible and it will update whenever you recompile the experiment. Pynapse starts in the always state by default, but we want to get into the pretrial state to start our trial loop. There are two ways to do this. One option is to use the General tab setting to define the initial state. Another option is to do it right in the code. Add the s_mode_recprev method in the always state. This method runs whenever Pynapse goes into preview or record mode. We can catch this event and switch to the pretrial state. I prefer the second option so that it shows up in the flowchart. All of the state IDs so far have been automatically generated. You can see the state IDs in the curly braces of the code tree. Recall the state epoch option that we left checked in the General tab. When a state change occurs, the state ID is timestamped with your data into this epoch event so you can use it later on for analysis. Once you start making recordings that you want to analyze, you'll want to lock these IDs in place so they are consistent across datasets. Then, if you add new states, their state IDs won't interfere with existing state IDs. Right-click on Main in the code tree and select Commit State IDs. We see the state ID equals question mark comments are replaced throughout your code with the automatically assigned state IDs in the code tree. The auto-generated state IDs are spaced by tens, so you can add states later on in between them and not mess up the ordering. Let's start a recording. Because we told it to switch to the pretrial state at runtime, our logic flow will be in motion right away. Let's edit the flow plot timeline up here to match our Pynapse timeline. Double-click the time axis and change it to 30 seconds. Metrics in the global category aren't tied to a specific time frame, so they are plotted on the timeline whenever they change. The default behavior of our experiment is to fail if there are no nose pokes. Use the mouse wheel to zoom in or out on the metric axes. We also get this ledger that shows the current value of all the metrics. These windows may be hidden depending on your screen size, so use these splitter bars to show them. We now have the state epoch event because we defined states other than the always state, and we can see it has our state ID values. Let's pause to take a look at the timeline. Here's the start of our trial. Nose poke was false, so it immediately switched to the trial state. The LED turned on, and since there was no nose poke before our 5-second timer was up, it switched to the incorrect state, turning off the LED on its way out. The failure counter incremented, and after 5 seconds it switched back to the pretrial state. We see the currently active state in red text here. There is a green checkmark next to the active state in the call tree as well. Note that this always includes the always state. Use the Expand Mode button to filter the information in the call tree to either just expand the current state or only show state time bars. When the debugging option is enabled in the General tab, you can also double-click on a state in the timeline to force Pynapse into that state. We can force a couple correct events for testing purposes. We can also use the iCon interface again to fake our nose poke input during the trial state to get to the correct state. And if we hold nose poke, we'll be stuck in the pretrial state. You can use the buttons at the top of the call log to filter out events from the always state, and to show every Pynapse event, including the state changes, in the log. Let's say our experiment requires that the subject holds the nose poke for a certain period of time before it gets the reward. We can use duration testing on the Pynapse input to define this. This created 3 additional slot methods. Let's say the subject must hold the nose poke for at least 1 second for a fixation period. We say the input becomes active and triggers an active slot method. Then the subject must continue holding for another 2 seconds for this input to pass. We'll use the pass slot method to move to the correct state. If the subject releases before the pass time has elapsed, it triggers the fail slot method. The RZ processor handles the precise time testing, and in Python we write methods that react to these active, pass, and fail input events. Here is our new experiment flowchart. It has a new poke fail state where the subject activated the nose poke but left too early, and a new invalid metric to count these occurrences. Let's add the invalid metric now. Let's add our new poke fail state after the trial state. It will increment the invalid metric and loop back to the pretrial state after a 5-second timeout. We changed the trial logic to capture the input pass-fail events instead of just the input rise event. Our generated flowchart now looks like this. Since we had previously committed our state IDs, the new poke-fail state is given an ID in between the other committed IDs around it. We can commit again to lock that one in too. Let's run this. In addition to the epoch codes 3 and 4 for the poke, we get additional values for the active, pass, and fail. The full list of values is here. Pynapse also has a built-in session manager that we can use to organize our trials into blocks. Say we want to run 20 trials at a time and capture metrics at the end of this block of trials to track the subject's performance. The session manager handles all of that for us. We enable the session manager in the Controls tab. After we do that and commit, we can see that the metrics we defined earlier can now be placed into different categories. A trial is one trip through our loop. A block is a set number of those trials, and a session is a set number of blocks. We'll use the block category and have the metrics automatically reset for the next block. Each metric can now be logged and plotted when the block ends. There is only one line of Python code we need to add for this. We need to tell Pynapse where we want a new trial to start. We'll add this at the start of our trial state. The p_session asset gives you a ton of information about the current session and methods to manually control it if needed. But since we set up the session manager in automatic mode back in the Controls tab, we just need to add the start trial method here, and the session manager will take care of the rest. We haven't looked at the data files on disk yet, but Pynapse saves the call log and console output with your other block files. But for metrics, you want a more human-readable format. In the General tab, let's turn on User Log File. This will let us save the metrics automatically into a file that a human or analysis program can easily read. After we enable this, we can go to the Metrics tab and log our metrics to this new log file. We can also go into the Controls tab and enable Log Session Detail. This will add timestamps of when the sessions, blocks, and trials started to the log file. Let's start a recording. Our metrics are now organized by block, both in the ledger and in the plot windows. Click this button to make the metrics vertical. We now get some interface controls to manage the sessions. We can set the number of trials per block and the number of blocks per session. A new session begins each time the Start button is clicked. Note that the trial loop is running, we're just not logging metrics for it yet, so the subject is still interacting while in the chamber, but the session hasn't started yet. This lets you start Synapse recording first, then put the subject in the chamber to behave, and then launch a session when ready. Let's do that now. Click the Start button. We can see this session number increment, and the next time it hits the trial state, which is where we told it to begin a new trial, the session begins. When the session begins, we can see the trial counter and block counters increment. Once the trial count target of 2 is reached, the block counter increments again, and the metrics that we have defined in the block category update on the ledger and in the block metrics plot. This tall vertical line is the start of a session, and our metrics are plotted next to it. Now if we go to the block folder on disk, we get a new log file of just our metrics values and session timestamps. Once your experiment logic is set up how you want it, I recommend disabling the debugging option in the General tab. You do this so that you don't accidentally trigger manual state changes or events during the recording. Thank you for watching this tutorial. In future videos, we will introduce the user controls and timer assets as we walk through specific examples. We hope to see you there.